A disk of mass m and radius r is placed over a plank of same mass m. There is sufficient friction between disk and the plank to prevent slipping. A force F is applied at the center of the disk. So we have to find out acceleration of the plank as well as force of friction. So first of all, we can see that on a plank, a disk is placed like this. So now on the disk, a force is applied at the center. F is the force. So there is friction between plank and the disk. So first of all, the friction on the disk will be acting in the backward direction. So this friction creates a torque. So first of all, like we will find out torque due to friction. Torque due to friction on disk. So this torque will develop an angular acceleration alpha. So given by tau is equal to F into R, frictional force into R, which is equal to I alpha. So again, F into R is equal to moment of inertia of the disk is mr square by 2, mr square by 2 alpha. So I got now F is equal to, one R is cancelled here, mr by 2 alpha. Next one. So let for example A1 be the acceleration of the disk, then net force on disk is given by mass into acceleration ma1 is equal to applied force minus frictional force. Equation number 2. Next one, we can see that on the plank, the frictional force is acting in the forward direction. Let A2 be the acceleration of the plank. So then I can say frictional force F is equal to. So let A2 be the acceleration of plank, which is only due to friction. Therefore I can take F is equal to m into A2. Equation number 3. So next we can see that now the plank as well as the disk both are moving in the same direction here, with acceleration A1 for the disk, A2 for the plank. So here we can see that net angular acceleration alpha is given by, so I can take now acceleration A1 minus acceleration A2 is equal to R alpha. Equation number 4. So now by using these 4 equations, we have to find out the acceleration of the plank. So we can see that now A1 minus A2 is given by R alpha here. And we can see that now frictional force is equal to MA2. So this frictional force can be taken as now MR alpha by 2. So I'll get now MR alpha by 2 is equal to MA2. So M is cancelled here. So I got now R alpha. R alpha is equal to 2A2. Some equation number 5 here. And from the equation A1 minus A2 is equal to R alpha, I can write now A1 minus A2 is equal to, in the place of R alpha I can take 2A2. So I'll get now A1 is equal to 3A2. So this is equation number 6 here. So many equations are there. Okay, so next we have to find out the value of the force here. Value of the A2 here. So we can see that from equation 2, we can see that MA1 is equal to capital F minus small f. MA1 is equal to force F minus F. So M in the place of A1 I can take 3A2 is equal to capital F minus, in the place of small f, in the place of frictional force I can take, so frictional force is given by M into A2. So now bringing this minus MA2 on the other side, will be getting 4MA2 is equal to F. A2 is equal to F by 4M. So acceleration of the plank is given by F by 4M. So next, so once we got acceleration, we can find frictional force. Frictional force is given by M into A2 here. So F is equal to m into A2 value is F by 4m. M is cancelled. The frictional force is F by 4. So acceleration of the plank is F by 4m, and the friction force of friction between disc and the plank is F by 4.